I'm a lecturer in the field of sustainable agriculture and agroecology at the Mbeya University of Science and Technology. But I'm also a PI in the project that aims to develop machine learning models that will help in the early diagnosis of common bean and Irish potato diseases based on CropImagery data. So this project is funded by IDRC and SIDA through ATPS and by other partners. Common bean and Irish potato are among major crops cultivated by most smallholder farmers in Tanzania and other parts of Africa. So these two crops are very important in the household economy as well as food security because they serve both as food and cash crops. But despite these benefits, yields are generally low, with an average of 0.9 tons per hectare for common bean and around 8 tons per hectare for Irish potato. But if you look at the potential yields under favorable conditions, should range from 1.5 to 3 tons per hectare for common bean and around 30 to 35 tons per hectare for Irish potato. So this low yields that is experienced by majority of the smallholder farmers is mostly linked to diseases, particularly bean rust and bean anthracnose for common bean, and early blight and late blight for Irish potato. So if these 4 diseases are not well managed, they can cause significant economic loss of up to 90%, and in some cases, total loss of 100%, for example, in late blight. So the model was trained on a large data set of common bean and Irish potato that was collected by the project team. And these data sets were labeled as either healthy or diseased based on their status. So this training data allows the model to learn the patterns and features that are associated with the 4 diseases that we are working on, because their pattern and label are quite different, and the model can pick up on that easily. So once the model is ready, it can be used to classify new images. So apart from the training data, once it's well trained, it can classify new images. So in this stage, farmers, agricultural extension officers, and other stakeholders in agriculture and food system can take or upload photos of either leaves of the affected or healthy plant that they want to know their status to the model, which will be deployed as a mobile app. So the model will then analyze the images and assign a probability that the plant is either diseased or not diseased. That means healthy. So if the probability is above a certain threshold, the model will classify the plant as the disease. This project from the beginning has been working with smallholder farmers and agricultural extension officers, and in some parts, very rural areas. So most of these farmers have farmers groups. They've organized themselves in groups. So we've been working with the farmers group, and one of the aim of this project was to empower smallholder farmers to use technology. But we encountered a problem or a challenge that most of the farmers group didn't own a smartphone. So we took initiative of providing a smartphone to some of the farmers group that didn't own one. And then we trained them and also we train agricultural extension officers on how to use a smartphone, particularly how to take pictures, good quality pictures of the crops that they want to diagnose, and how to use the app. And like I said, this app will be available for free. And in addition to that, it will be in Swahili language. This is the language that is widely spoken by smallholder farmers across Tanzania and some other parts of East Africa. But some of the features of this app will be available in offline as well to cater for the limited internet connectivity, particularly in rural areas. So this will help to ensure inclusivity and accessibility across the entire agricultural sector. So, like I said, the model will analyze the patterns and correlation within the vast data set that was used to train for the crop diseases and associated management strategies. And after that, the model will tailor recommendations based on the specific crop, let's say if it's a common bean or if it's a Irish potato, and then the disease type, and also the environmental condition of that particular area. So this personalized approach will empower smallholder farmers to implement effective and timely disease management strategies that will help to minimize crop losses and optimizing agricultural productivity. In this project, agriculture extension officers are key in connecting the tool that you are developing and farmers. So the agriculture extension officer will receive training on how to use our machine learning tool to diagnose crop diseases and what should be done to manage and control the disease. But they will also provide education and assistance to farmers because we will work closely with these agriculture extension officers and we will train them, but they know better how to communicate with farmers. So they will help us provide education and assistance to farmers by helping them to identify early signs of diseases using the machine learning app, and also implement appropriate control measures that will help to combat the diseases. And smallholder farmers, I will say these are the first line of defense against crop diseases, because in most cases they're the ones that are likely to encounter and notice early signs of diseases in their farms, particularly when they do this morning scouting their farm to look for signs of diseases. So smallholder farmers can also play a big role in preventing the spread of crop diseases by managing or by reporting them as early as possible to responsible authorities. And this is where our machine learning app will be of great use, because it will accurately help the farmers to detect these diseases as soon as possible, and then maybe they can report it to the agricultural extension office and then see what can be done better to either reduce the spread or to completely stop the disease. Other stakeholders such as researchers, government agencies and private sector can also play a big role in this early diagnosis of crop diseases. And for our project, apart from developing the machine learning model, we have also collected and deposited in public repositories more than 124,000 leaf images. Purposely, we did this so that other researchers working in the same space to access and use the data to diversify disease diagnostic options. So they don't have to go to the field and collect the data. They can use our data as training data and then develop other tools that will help smallholder farmers in other areas to diagnose disease and manage them better. Responsible AI, this is fairly designing or developing AI with good intention to benefit the society. And our project has observed the responsible AI practices right from its beginning, from data collection all the way to the development of machine learning model. For example, in order to promote accountability and transparency during data collection, a concept form was designed which describes the purpose of the project, types of data that will be collected, and how such data will be used. And this consent form was given to participants prior to the start of interview in order to get their permission to continue. But also the project abides to data privacy and protection. And there are laws that guide us, laws in the country. For example, all personally identifiable information, which include names, gender, personal contact, physical address, and so on. So if you want to gather this information, you should get a consent from the participant, and we'll be doing that. And we'll also tell the participants that this data only be used for internal purposes, that is for monitoring and remunerating data collection activities, but it will not be linked to any opinion, that because you mentioned your name or your gender, then we'll link your opinion to your name. So it was just purely for internal purpose, that is monitoring and monitoring data collection activities. Again, on the issue of carbon footprint reporting has become an important topic, particularly in the AI system recently, given the raised concern on the AI model development and the tremendous energy that they need and they use. Therefore, it is very important for AI projects to have a plan to reduce their carbon footprint or to report their carbon footprint. And our project have accomplished that by, first, from the beginning, we emphasize the use of electronic messages for both internal and external communication with the team and also with the funders and other partners. This will help to reduce the use of papers by printing documents. But also data collection was purely done using digital tools. We use Open Data Kit to collect all the data, so we also eliminate the use of paper. And most of the project meetings were conducted virtually to reduce the physical meeting that will require, for example, because we have different team members. So we require some of them to travel 1,000 kilometers by road, and this will contribute to more carbon emissions. So all the meetings were conducted virtually to reduce that. Also, we used efficient AI and machine learning algorithm that require lightweight and energy efficient computers. And also we use Code Carbon to track all the carbon footprint, and this is included in the reporting. So it is within the threshold level. And on top of that, the project procured and uses renewable energy such as solar to power all the electronic devices such as computer and mobile phones. And this was also the case during fieldwork. So during fieldwork as well, we have portable solar chargers that we use to charge our equipment. Agriculture in Africa faces a number of challenges, and these challenges hugely affect food productivity. And as we know, the population of Africa keep on increasing, so we need to produce more food to cater for the needs of rapid growing population. But through the use of emerging technologies such as artificial intelligence, machine learning, Internet of Things, and so on, there is a potential to transform this traditional agriculture that Africa has been practicing into a sector that is productive and sustainable. So I encourage other researchers and other stakeholders as well to take advantage of this emerging technology and use them to enhance agricultural practices and strengthen the resilience of farming communities in Africa.